Hi guys, greetings of the day. Welcome to my YouTube channel for learning a subject called Fluid Power Engineering for 5th semester and Fluid Power Systems for 7th semester as per VTU syllabus. If you haven't subscribed to my channel yet, kindly subscribe. Also click on bell icon to receive the latest lectures as and when it is uploaded in my YouTube channel. Now let's begin the session number 49, which is based on control diagram. What is called as control diagram? Control diagram are those which represents the condition of control elements in relation to steps or the times. The switching time itself not being considered. Example, control diagram for a valve you can see in the figure which shows the control diagram of a 3 by 2 roller actuated spring return valve. It can be observed from the control diagram that the valve opens at step 1 and remains open till step 4 and closes at step 4. It can be observed that the function lines are suddenly rising and dropping, indicating that the opening and closing of the valves are instantaneous and not gradual. And recommended procedure for control diagrams and how to write that. The control diagram should, if possible, be drawn in conjunction with the motion diagram, and steps or time should be entered horizontally, and height or separation are optional but should be selected to ensure clarity. The combination of motion and control diagrams are called the function diagrams. Then let us understand more clearly about what is called a signal overlap. A memory device or a wall may receive signals from both ends from pilot walls. There may be a situation where signals are fed to both ends of the wall at a time, or a signal already exists on one end and the other signal is applied on the other end without removing the signal already applied at the other end. Such situations are known as signal overlapping. Example, signal from limit switches and manual controls which are still operated when opposing signal occur and they do not permit this opposing signal to be effective. Signal overlapping will not take place provided in two signals are of different intensities and the signal of higher intensity predominates, the lower intensity signal becomes inoperative or insignificant. In such cases, the signal of higher intensity must be eliminated or removed and made ineffective. If the signal of lower intensity were to be effective, this is a common phenomenon in walls actuated by two signals, and methods have been evolved to eliminate the signal when not required or to make it effective when necessary. Signal overlap is a very common recurring problem in control engineering. Examples of signal overlap. In a coordinated motion, the 5 by 2 memory wall, the wall can switch positions only when single pilot signal is present. If two signals are active on 5 by 2 wall simultaneously, then such situation or condition is called signal overlap, which you can see it by the figure over there on the heading called a signal overlap. Then what is the solution to signal overlap? In pneumatics, there are various possibilities for eliminating the undesired or unwanted signals. One must distinguish between the two main groups of signal overlaps. The signal which is still applied is overridden by a stronger signal is called signal suppression. And the second one is the applied signal is cut out, that is signal cut out is going to happen or it is going to be eliminated. Now, how the signal suppression will take place, we will understand the same. In case of the signal suppression, which is still applied, is overridden by a stronger signal, and the figure shows the circuit diagram for a signal suppression, which contains a directional control valve with a differential pressure operation, or by means of a bistable valve with a regulator on one of the control sides. Here, signal 12 is overridden by signal 14, which you can observe. In terms of functions, both methods are equally good. However, to ensure reliability of operation. It is necessary in the case of a differential pressure operation that both the signals 12 and 14 have the same pressure level, or for chosen pressure, the difference in case of using bistable valve, the difference in pressure between the signals 12 and 14 must be of sufficient magnitude. Then coming to the next concept, that is called as signal elimination technique. In this technique, it is possible to eliminate the signals either mechanically or by means of suitable circuitry. Now let us understand a concept called as mechanical method. In this method, the signal elimination is by means of short impulse transmitter, or even it could be idle written roller. Short impulse transmitter method, it comprises of directional control valve with over center functional and the respective type of control. When using such type of valve, one should have the following points in the mind. The operating reliability depends on a great extent on the speed of actuation, that is maximum 0.1 to 0.15 meter per second. And the valve is actuated in the middle part of the stroke and not at the ends of the stroke. That is, the actuator must be operated as far from the stop, otherwise a continuous signal will exhaust. In case of idle written roller can be used if the signal to be eliminated is provided by a limit switch. The use of roller levers valves with idle return to eliminate signal overlapping has the following disadvantages. Namely, first one, the end position cannot be sensed accurately. Second one, the function may be impaired due to contamination. And last but not the least, fast control of systems are not possible. And several possible solutions are available to this problem. However, the first signal overlap points must be established. Let us understand this by more clearly by an example. Consider a coordination motion of two cylinders. The sequence of motion of the cylinder being as follows. Step 1, cylinder 1A extends. Step 2, cylinder 2A extends. Step 3, cylinder 1A retracts. Step 4, cylinder 2A also retracts. And step 5 is going to initial position. Now signal overlap occurs in steps 1 and 3. In the initial position, the signal is applied at the control port of the double pilot valve V1 via actuated limit switch 2S1. Now, if the push button of 1S1 is actuated, a signal is applied at the control port 14 of the double pilot valve V1. Here, the signal at 12 and 14 is getting overlapped. Similarly, a signal overlap occurs at the double pilot valve V1. The extension of cylinder 1A actuates the limit switch 1S3. The cylinder 2A extends and actuates the limit switch 2S2, which triggers the signal for the immediate retracting of the cylinder. If the limit switch 1S3 is still switched at this point, two signals are applied simultaneously at the double pilot valve V1 and the valve cannot switch over. Signal overlapping can be eliminated by use of lever valves with idle return as limit switches. These valves are actuated in one direction of movement only by piston rod and are configured in such a way that the actuation is triggered just shortly before reaching the respective initial end position. In circuit diagram, an arrow is shown at a cylinder 1A and 2A at the limit switches 2S1 and 1S3. The direction of arrow switches in which the direction over travel of the roller lever valve with idle return leads to actuation. No actuation takes place in case of over travel in the opposite direction. And also we'll understand more clearly what is called as signal elimination by reversing valve. Signal elimination by means of a reversing valve is a frequently used solution. The principle in this case is to allow the signal to be active only for the required length of time. This is achieved by blocking the signal downstream of the signal element by means of a reversing valve or by supplying energy to the signal element only when the signal is required. A double pilot valve is used for the effective operation for the reversal. That is called as reversing valves. That is what we have discussed. Now, by this, I would like to conclude the session. Thanks for your patience listening. If you have any sort of doubts, feel free to use the comment section for further discussion. I will answer all your questions related to the topics covered in this session. Don't forget to like, share, and subscribe. Have a great day. Signing off, Vijay Tavardhan.